Alright, hey guys, so welcome back again to the third part of this 2017 paper. We had posted two videos earlier that brought us from questions 1 through to 6. Do check that out if this is the first time that you're clicking on this video or on this channel. We are now going to proceed into question 7 through to the end, so please ensure that you pay close attention to the information being provided. Lots of details will be provided for you, so take this lesson on to the next video that you're going to be watching on the channel. Alright, so like I said, if this is your first time on the channel, please be sure to subscribe if the videos are helpful to your needs. Okay, alright, so let's get into it. We had closed off at question 6 and now we are proceeding into question 7. So the table below shows the speed to the nearest kilometer per hour of 90 vehicles that passed a checkpoint. In column 1, we have the speed in kilometers per hour. In column 2, we have the frequency. And in column 3, we have the cumulative frequency. Alright, so we have some values that are missing here. I'm pretty sure that they're going to ask us to fill that out. And these numbers, these ranges that you're seeing here are called class intervals. So we're going to be discussing that in a moment, and of course the frequency column is filled out. So let's get into the question. So they're asking here for the class interval 20 to 39, as written in the table above. You have to complete the following sentences that apparently is related to this class interval here. 20 to 39. We want the upper class limit. Alright, now in a class interval, every class interval has an upper limit and a lower limit, and just the way how the word or the sentence sounds, upper limit, lower limit, it's evident that the lower limit would have to be the lowest number that makes up the class, and the upper limit would have to be the bigger number that makes or that ends the class. So clearly you can see that the upper limit of the class 20 to 39 is obviously going to be 39. Alright, so that was not too bad for you guys. We are interested in finding what is the class width. Now there's two ways that you can find the class width. I'm going to show you the traditional way, how a teacher would tell you to find it, and then I'm going to show you an alternative method. Alright, now it is said, or it is taught mostly, that the class width, in order for you to find the width of the class, you have to find the boundaries of the classes or of that specific class that you're looking at. So our primary focus is going to be on the class 20 to 39. I think I'm going to need a bigger space here. So I'm interested in the class 20 to 39. And now we're going to have to find the boundaries. And the boundaries of this class is that we're going to be adding 0.5 to the upper limit, and we're going to be subtracting 0.5 from the lower limit. So subtracting 0.5 from 20, that will leave us with 19.5. And adding 0.5 to 39.5 is going to give us 39.5. So what that means for us is we're now going to just say that class width is equal to the upper bound minus the lower bound. And so the upper bound of that class is 39.5. and the lower bound is 19.5, and so this is now equal to 20. So the width of the class is 20. Now alternatively, we could also, instead of finding the boundaries, because it could be a case where you have to find all the boundaries for the class interval, and that's going to take a little bit of time, right? When I say a little bit of time, maybe a minute and a half, but that's still a lot of time. But what you can do is that, remember that the width of the class, or the width of one class, is going to be the width of all classes. Alright, so no class doesn't have a different class size. So what you can do is that you can utilize the limits. So we could simply say that the class width is equal to the upper limit plus the lower limit. I'm going to put that in a bracket, and after doing that we're going to add 1. That will still get us to the answer of 20. And I kind of like using this method because sometimes, for me personally, thinking from a student's perspective, I've heard students mention that they don't remember what to add 0.5 to or subtract 0.5 from. Some students may add 0.5 to one part and forget the 0.5 to the other part. And there are some students who will misinterpret what I say when I say subtract 0.5. They end up subtracting 5. So I want to avoid anything that might misdirect us. So if we can use what we have to get to where we want to get to, the only thing you need to remember is just to add 1. Alright, so let's see. So the upper limit is, I'm sorry, and this is not plus, sorry, this is minus. So the upper limit is 39 and the lower limit is 20, and that's going to be plus 1. So that's going to be 19 plus 1, which of course again is equal to 20. Alright, so this is what my videos are all about. It's not about working out the past papers and telling you just telling you the answers. The idea behind why I work these past papers, guys, is to ensure that you have an alternative. Wherever I can provide you an alternative method to work in the questions, I like to give my students or my viewers options to working out questions. Alright, so hope that was good for you. Now we're interested here in part 3 to here we're interested in, it says following sentence, 16 vehicles passed a checkpoint at no more than. So we want to find out what's the kilometer, what's the maximum kilometer at which 16 vehicles or no more than 16 vehicles passed. What's that kilometer? So we can evidently see here that there's a 16, which kind of just, catches the eye. I'm sure that if you're looking at the past paper physically, you'd also see that 16 there. And it would also catch your eye. So what is the limit? You see, the cumulative frequency is a very interesting concept. I'm sorry. Because for me, it's just it's pretty much adding up the frequency as you go down further, or you go higher and higher up into the class intervals. So it's adding up the amount of vehicles that pass the checkpoint every time you go to a new class. That's in essence what it's doing. So right here, what this 16 or what this 5 or what any of these numbers are going to tell me, it's going to tell me that 16 vehicles, or there was a total of 16 vehicles that were recorded passing the checkpoint after the speed 39 kilometers per hour. Because this is the upper limit of this class. So at this point, at this 39 kilometers per hour, there was a total of 16 vehicles that were recorded. So no more than 16 vehicles had passed the speed of 39 kilometers per hour. So that tells me the answer for this question here. 16 vehicles passed the checkpoint at no more than 39 kilometers per hour. Alright, pretty good. A lot more emphasis will be placed on what the cumulative frequency is in future tutorials, so do look out for that. Next part, we have to complete the table shown above by inserting the missing values of the cumulative frequency column. So in order for us to complete the cumulative frequency, as I mentioned earlier, guys, that the cumulative frequency is pretty much just adding the amount of vehicles that is passing the checkpoint after the maximum limit of each class. So as you can see here that 5 vehicles were recorded at a maximum speed limit of 19 kilometers per hour. After the speed increased to 39, a total of 16 vehicles were recorded. So how did they get this 5 and this 16? Well, we don't know what the speed limits. Well, obviously the lowest limit here is 0, so obviously that the vehicle would have been at rest. So we are going to assume that no vehicle went at a speed limit less than 0. So 0 would have been the frequency here. So for cumulative frequency, the first frequency value always matches the first cumulative frequency value. And then what happens for us to get the 16, we realize that there was a total of 11 vehicles that passed the checkpoint that were traveling at a speed between 20 and 39. But in total, the number of vehicles that were recorded that had a speed between 0 and 39 was 16. And that is simply because of the 5 vehicles that were in between the distance of 0, in between the speed of 0 to 19, and the 11 vehicles were recorded between 20 and 39. So it's summing up the 5 and the 11 to give us 16. So in order for us to get it then, I could just get to the point and just tell you that we're just going to be adding the 16 to the 26. Yes. And that's going to give us 42 vehicles. So what this 42 means is that there were 42 vehicles recorded traveling at a speed between 0 and 59. We're going to add the 42 to the 37, and that should give us 79. So again, what does this mean? The 79 means that there were 79 vehicles recorded passing the checkpoint between 0 and 79 kilometers per hour. We're then going to be adding the 79 to the 9, and we're going to be getting 88. So 88 vehicles were recorded passing the checkpoint between 0 and 99. And finally, 88 plus 2 is 90. So a total of 90 vehicles were recorded traveling between a distance of 0 and 119 kilometers per hour. So in summary then, just to ensure that you have a proper understanding of what the cumulative frequency is, it is just the sum of the frequencies from the lowest speed to the point of maximum speed at which you're at currently. So it's cumulatively adding up the frequencies as we go along. Alright, good. I'll try to put out a tutorial to give the whole idea of cumulative frequency concept, right? Hopefully if you're interested in that. So we have completed the table. Let's move on up. On the grid provided on page 21, you're using a scale of 2 centimeters to represent 20 kilometers per hour on the x-axis and 2 centimeters to represent 10 vehicles on the y-axis. And you're to draw the cumulative frequency curve to represent the information on the table or in the table. Now, before we get into all of this, there's an important concept here that sometimes, depending on the question, that column is created for you. And there are going to be situations where this column will have to be created by you. And so it's not there and it's not instructed. However, it is something that is mandatory. And that column is going to be called your midpoint column. So I'm going to put mid for short. I'm going to put the symbol that we use for midpoint, X. Alright? Now, we're going to find a midpoint and then I'm going to tell you what's the purpose of the midpoint. So here we go. So in order for us to find the midpoint, we're simply going to be adding the limits of each class and dividing by 2. Yes? So lower limit plus upper limit, divide by 2. So here we have lower limit 0 plus upper limit 19. That's equal to 19. And if we divide that by 2, we get 9.5. Let's go again. Lower limit 20 plus upper limit 39 divided by 2. That's going to give us 29.5. And at this stage, you would get the idea that you're going to be adding 40 to 59 dividing by 2, 60 to 79 divided by 2, 80 to 89 divided by 2, 100 plus 119 divided by 2. And whilst that is also a very easy method, it's also a very timely method. So here's one way how you can get your answers real fast without doing much addition, subtraction, dividing, and that kind of stuff. Remember earlier, we had found the class width to be 20. And we mentioned that the class width of one class is the class width of all classes. So there are going to be questions where the class width may be unknown. It may not be a requirement, but you could actually utilize this to the side. Maybe you could just jot it down somewhere by just finding it, just write it down. You don't know if you're going to be using it. In this case, it so happens that the question on the paper required us to find the class width, and also finding the midpoint was also a necessity. So with those two information, this tells me that I'm going to be increasing my midpoints by 20. All right. So you can see that the difference between this midpoint and this midpoint, if you go on the calculator and you type 29.5 minus 9.5, you're going to get 20. So it must mean that this 20 has a significance with my midpoints. So that tells me that I'm going to now have 49.5 here. All right, then I'm going to have 69.5. See, I'm getting my answers and I'm not even looking at these upper and lower limits, because that can be quite timely. So it's going to be 89.5, and it's going to be, let me see here, 109.5. All right, and that is how you find the midpoint. Pretty easy. So once you know these little shortcuts, if you want to call it that, then you know that finding certain values on the table is going to be quite simple. All right, so I'm happy to show you that method. But if you feel the need to take the safer route, if you think you won't remember that, it's fine to go ahead and go on your calculator and press 60 plus 79 divided by 2, 80 plus 99 divided by 2, that kind of stuff. That's perfectly fine too. Because like I said, when you're drawing the cumulative frequency, this may not be there, but you have to remember it is a must. Now, why is it a must? The midpoint is the midpoint values is just a representative for each of the class that you see here. All right, and it's also a necessity for finding the mean from a group table. This is a group table that you're looking at. So it's just a representative of each class. 9.5 is a representative of the class 0 to 19. 29.5 is a representative of the class 20 to 39, that kind of thing. All right, so that's why we need it. So it's going to be the values that we're going to be finding along our x-axis. Now, we are drawing a cumulative frequency. So we know that the y values will be our cumulative frequency values. All right. Normally, if we're drawing a frequency polygon, then we'd use the frequency values. But we're drawing a cumulative frequency curve, so we're going to be using the cumulative frequency numbers here as our y values. All right. So they gave us a scale. The scale is 2 centimeter to 20 on the x, and it's 2 centimeter to 10 on the y. So let's get to that. It can be a little difficult for my system that I'm using here to draw the scale, because sometimes it takes a little bit long. So let me see how accurate I can be. All right, but you guys should be able to do this a lot more accurate than I am. because you just need to have your ruler and make sure that you have a straight line coming down like that. It's a little lean, guys, but I just hope you get the concept. It's just the idea that I want you to get. Right? Use your ruler and make sure that this is straight. Okay? Let's put on our scale. So they're saying to us here that it is 2 to 20 on the X. Let's double check that. So let's verify that information. So it's 2 to 20 on the X-axis. So every 2 squares is 20. So let's go here. So this is 1 square, 2 square. So the second square is going to be 20 kilometers per hour. 1 square, 2 square, that's going to be another 20, so that's 40 kilometers per hour. 1 square, 2 square, so that's 60 kilometers per hour. I think we have to go as far as 120. 2 squares, that's 80 kilometers. 2 more squares, that's 100. 2 more squares, that's 120. Alright? It's going to be, like I said, guys, I'm using a very small screen at the moment, so it's going to be a little difficult to like plot the point, but I hope you're following the idea, the concept. Let's label our axis. This is going to be speed in bracket kmh minus 1. Put a dash there. Okay? So we have to label our axis. Let's label our y-axis now. So you're going to label it to the side. Let's put on the scales first. Okay, here we go. So the scale that was required for the y-axis, let's go back here. It's going to be, let's see here, 2 to 10. 2 to 10. So every 2 squares is 10. Another 2 squares, 20. Another 2 squares, 30. 40. I think we have to go as far as 90 because there were 90 vehicles. 50, 60, 70, 80, and 90. That's as far. And we're going to label, well, we know that this is going to be the cumulative frequency. Alright. Now, what I'd like you to do before we jump ahead and start plotting points and that kind of stuff, what I want you to do is to have an understanding of the little light lines in between the scale. I like a lot of students to do this because sometimes these little strokes here, a lot of person will think that each of them represent 1. So it depends on the scale. Now, here's how you can easily figure out what each of these light lines in here means. The first thing you need to do is to determine the space between here and here. And evidently, it's going to be 20. So this is 0. Now, if there are 10 strokes inclusive of this midpoint here, this line, including that, if there are 10 of these lines all the way up to this 20 here, then it means that you divide this first value by the amount of lines, and then it will tell you what the value of each line is. So this is 20 divided by a total of 10 lines. So each of these strokes represent 2. So if you want to make a note of that, you can say each equals 2. Just a note for yourself, for your purpose. So now that we have an understanding of what that is, remember, an easy way to do it is just take this number, or one of these numbers, and divide it by the amount of squares, or the amount of lines between the point before it to the point that you're currently at. And it will tell you the value of each of these lines. For this one, from here to here is 10. And there are also 10 lines between here. So 10 divided by 10 is 1. So each of these lines on the y-axis represent 1. Each of these little light lines here represent 1. So I think I have that in my head, and I hope you guys are following. Let's get into it. So the midpoint values are going to be the values lying on the x-axis, and the cumulative frequency are going to be the values lying on the y-axis. So we're first going to have to match 9.5 to 5. I don't want to rush this, guys. You want to take your time and make sure that you get this right. So we're looking for 9.5. Now, evidently, if this is 0 and this is 20, then right in between must be 10. Alright, so we know that right here is 10. We know that much. Yes? Now, if this is 10, and each of these lines represent 2, we just discussed that, then this must be 2, this is 4, this is 6, this is 8. So right in between must be 9, and somewhere in between, this is an estimate. So we're going to say that 9.5 is in between this fourth line here and this bright midpoint line here. So it's somewhere in between here. I'm going to go all the way up to 5. So right here is going to be our value. Let me use a different color ink here. Red. So we're going to have, zoom it out a little bit. All right, good. Here we go. 5. That's the first point. Like I said, it's a little bit difficult, guys, for me to really pinpoint. So you got to pay attention for me. All right. On your paper, just make sure that you're following right where I'm at. Pause the video and look at it first, plot it, and then move along. So this might take a little bit of time, but I'm going to take my time and actually go through it with you. All right. In future tutorials, I may just refer you to this video. 29.5 to 16. So we want to look for where the intersection of 29.5 and 16 is. So evidently, between 20 and 40 must be 30. Yes? So again, it's just going to be right in between this section here. In between here. Right? Right just before 20, in between that space. I'm going to go all the way up to 16, which is going to be right here. Right there. That's the point. Alright, that's the position. And let's try to move along. It's a little fine, but I know you guys get it though. So we're going to record a few in our head. We know that we're going up by 20, so I won't need to remember what these are, because I'm at 29.5, so I know that the next one is 49.5, 69.5, that kind of thing. So I want to have these in my head. So I know my next three numbers are going to be 42, 79, 88, and 90. So I'm going to write them down over here. 42, 79, 88, and 90. 42, 79, 88, and 90. That's going to be the values on my y-axis. Alright, because I can't be bothered to be skipping from page back to page. So we have those. Alright, so my next number is going to be 49.5 to 49.5 to 42. So 49, evidently again guys, between 40 and 60 must be 50. So 49.5 must be somewhere in between here. And I'm going to go all the way up to 42. So 42, we know that each of these strokes here represent 1, so 42 is going to be right here. Alright, that's 42. It's a little fine, guys, but you're seeing it clearly on your paper. 69.5, in between 60 and 80 must be 70. So 69.5 must just be here. So we're going to go all the way up from 42. We said that our next number is going to be, what was that, 79? So we are somewhere in between here. 79. Okay. Not quite there. So 79 must be right here. So here is 79 here. I just want to see where it's at. So we are about here. So we are about here. I think I've lost it a little bit here, guys. I think we're here, right? I think that's it. All right, so I'm gonna work with that. Then now we're at 88. So from here, I'm just gonna skip 2 spaces. I'm gonna go to 88. So that's right here. So 1, 2, and go up to 88. That's it. Oh, that's 89. This is 88. Where's that bottom one here? Then we're gonna skip 2 spaces. We're gonna go to 90. Alright, so I do have my points. It's a little difficult for you to see on the screen, but I think I have it to a certain extent. So I'm gonna go ahead here and proceed. So you should have something looking like this. Let me know in the comment section, guys, if you got something looking like that. And don't forget to label. Don't forget to label your curve or your graph. So you're gonna have cumulative frequency showing. Don't have enough space to write out everything that I'd like to write, but you're going to be showing that number of cars that passed a checkpoint, and that's going to be the title of your graph, and that's going to be your cumulative frequency curve. All right, so I hope you guys get the whole idea of the plotting. That's very important. Forgive me for my space. I'm going to be working on a different system that's going to allow me to have a lot more space for you to work with. Alright, so we're good. We've gotten that 4 marks there. Now it says, on your graph, draw reference lines to estimate. So when you see that word estimate, it means that somebody be sitting beside you, behind you, or in front of you might get 1 less or 1 more than the value that you got. So it depends on how close to perfect your graph is drawn. So on your graph, draw reference lines to estimate speed at which no more than 50% of the vehicles drove as they passed the checkpoint. So guys, there are 90 vehicles that passed the checkpoint. So 50% of that is 45. So we go on our curve, and we're looking for the speed at which 45 vehicles passed. So we're looking for 45. 45 is evidently between 40 and 50. So I'm going to go across like that. Oops. So that looks to be, let me zoom it up here, that looks to be the very first line after this bold line here. So this is the bold line that we're looking at, 50. And remember that each of these little strokes here represent 2. So if this is 50, then this first line that we just said that it's the first line, it seems to touch the curve after that first, at that first line after this midpoint line here, then it must mean that my estimate, and just let me know in the comment section, guys, if you get the same thing or not. The answer for that I got is going to be 52 kilometers per hour. So the reference line is for here. That's the 1 mark for the reference line. And just writing down the answer here, 52 kilometers per hour. is the answer. Okay, and that completes our cumulative frequency for the year 2017. So I hope you guys got a lot of knowledge out of that. Alright, it took quite a bit of while, but the whole idea is not how long it takes, it's just what we learned from the paper. So we're now going to move on now to pattern and sequencing. So the first 4 figures in the sequence are shown below. Figure 1 is a single black dot, while each of the others consist of black dots arranged in an equilateral manner. So it means that with the word equilateral, it means that the sides of the apparent figure are equal. There's going to be 4 dots here, 4 dots here, 4 dots there, 3 here, 3 here, 3 there, 2 here, 2 here, 2 here. Well, that's just one. So you have to draw figure 5. So figure 5 will obviously have 5 dots here, 5 dots here, 5 dots here, and some in the middle. So let's see how best we can draw this. So 1, 2, 3, 4, 5. This is 1 already. 2, 3, 4, 5. That's 1 already. 2, 3, 4. And that's 5. So we're going to fill out this space here. Alright, so that's as close as I can get it. Alright, so you can see 5, 4, 3, 2, 1. There's just different ways how a student can look at this and see exactly the arrangement. Alright, so I think I've gotten it right. Okay, so that's just going to be your figure 5. How many dots would figure 6 have? Now, we've got to be we've got to see some sort of pattern here. We've got to figure out some sort of pattern. And I'm just going to be showing you the pattern that I see. Feel free to leave it in the comment section if you see an easier pattern than I saw. Alright? So, what I'm looking at here is the fact that I'm looking at the difference between the amount of dots that each figure has. This figure has 3 dots. This figure has 1, 2, 3, 4, 5, 6. And this figure has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this figure has 1. So 1, 3, 6, 10. Is there a pattern between 1, 3, 6, and 10? Is there a consistent pattern? Is there some sort of thing that's happening? I realized here also that this figure we increase from this figure to this figure by +2. That's what I saw, +2. And we increase from this figure to this figure, we increase by +3 based on the amount of dots between each figure. And with the difference between these two figures, the amount of dots is +4. So 1, 3, 6, and 10 represent the amount of dots that are in each figure. But the 2, the 3, the 4 is the difference between the adjacent figures. So if I increase from figure 1 to figure 2 by +2, from figure 2 to figure 3 by +3, figure 3 to figure 4 by +4, then it means that from figure 4 to figure 5, I'm going to be increasing by +5. And then that will tell me right away that this figure 5 that I'm looking at here must have 15 dots, because 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, so 10 plus 5 is 15. Now, when I drew figure 5, I didn't count the amount of dots. I just arranged it according to how I see the pattern laid out. So let's check to see if it's actually 15 dots, just to verify the pattern that we are seeing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and we are correct. So there are 15 dots here. So we pick up a little pattern, right? There's a little pattern because jumping from figure to figure, the difference is just going to be going up by 1. So again, let's run by this again. Figure 1 to figure 2 plus 2, figure 2 to figure 3 plus 3. And that's this number here, this plus 2, plus 3, plus 4, plus 5 is just the amount of dots extra that the next figure has. So figure 3 to figure 4 plus 4, figure 4 to figure 5 plus 5. So obviously figure 5 to figure 6 must be plus 6. So 15 plus 6, that tells me that figure 6 must be equal to 21 dots. That's kind of like the pattern that I saw. Alright? And apparently another thing that I also see, because when I was working this out, this is the pattern that I immediately saw, but now looking at it again, apparently I'm seeing here that based on the figure that you're going to next, that's the additional dots that you're going to have. So it means that figure 7, going to figure 7, must be 7 extra dots than what the previous figure had. Figure 8 is going to be 11 extra dots. Sorry, figure 8 is going to be 8 extra dots more than what figure 7 had. I hope you guys got that idea. So that's another pattern that I saw. So in essence then, just to summarize all of this, the figure that you're going to be drawing will have that amount of dots extra than the figure before it. Alright, so figure 6 will have 21 dots. Feel free to leave it in the comment section, as I said, guys, if you see a different pattern. Alright, pretty good. Now we have a table here. Alright, and usually this is the case, where a formula of some sort is created. I mean, naturally, there must be, there has to be maybe 2, 3, maybe 4, or even more formulas that can be created to get 1, 3, 6. But this is what they came up with. What they're saying here is that for you to get the amount of dots in each figure, figure 1, 2, 3, and so on, 11, and so on, and n amount of figures, whatever n represents, could be 500, 1000, whatever the case may be. The formula for getting that is going to be a half multiplied by the figure multiplied by the figure plus 1. So half times the figure that you're actually trying to get the amount of dots for, multiplied by the actual figure plus a constant 1. So let's look at what is repeating itself. It seems here that half seems to be a constant multiplier. 1, 2, 3, so you can see that this is increasing by 1. So evidently this must equal to the figure, or the apparent figure that you're working out. Multiplied by 1, 2, 3, again is increasing, so this, and this all looks the same. So apparently this number here must also be the figure that you're currently drawing. And then 1 is repeating itself, so that must be the constant of 1. Alright, so there's an empty space here, and there's an empty space here. My assumption, without even looking at the question, I'm assuming that they're going to tell us to work out here and here and here and here. So let's see. We don't want to do what is not asked of us. We just want to do what is required. So part C here is that we're to complete the row which corresponds to figure 11 in the table above. Alright, so we need the formula to go here. Alright, so we know that half is repeating itself. And we're going to now multiply it by the figure. And in this case it's 11. And we're going to multiply by, open a bracket, it's going to be the figure again, which is 11 plus 1. And all we have to do to get the amount of dots that is in figure 11, we just work this expression out, this equation here. It's not an equation, but we're just going to work it out. Alright, so we're going to have, I'm just going to work it out and then erase the working out. You could just do this in your head. It's just half multiplied by 11 times 11 plus 1 is 12. Alright, now a half is 0.5. So if you're the type of student that's going to be using a calculator, you can just go on your calculator and you can press 0.5 multiplied by 11 multiplied by 12. That gets you to your answer. Or you could just go on the calculator again and press 1 divided by 2 times 11 times 12. Okay, so we could pretty much just not use the calculator and we could just say half of 12, that is 6. 6 multiplied by 11 is 66. I think I get my answer an easier way. Alright, I'm not a big fan of using the calculator, but you can also use it to verify. Alright, so right here I'm not using the calculator anyways. So that's the answer, 66. So I'm just going to erase this calculation here. Okay, we wrote this the incorrect position, so this is 66. Okay, pretty good. Alright, so for 2 more marks, we are to determine which figure in the sequence has 210 dots. 210 dots, 2 marks. So we have an equation. We're looking for the figure, so we're looking for n. Looking for the figure. So our variable, or unknown variable here is going to be n. So we know that it's going to be half multiplied by the figure that we're looking at, multiplied by open bracket the figure that we're looking at, plus 1. And whatever this figure is going to be equal to 210. So let's work this out. A half multiplied by n, if you want, you could just write a half n. I think I'm just going to write n over 2. Alright, because this is 1 times n, which is just n over 2. Open bracket, we are not allowed to add 1 to n because it's unlike terms, and that's equal to 210. Alright, so we have this denominator here of 2. We're going to multiply both sides by 2. So I'm going to write it down for you. It's going to be 2 multiplied by n over 2, open bracket n plus 1. And that's equal to 2 multiplied by 210. So these 2 cancel. So what we're left with here is just n, open bracket, n plus 1. That's equal to 420. Oh, this is looking like a quadratic. For 2 marks, I think that's quite stingy, CXE. That's quite stingy for 2 marks. I think you should have given it a bit more, maybe like 4. Let's see, n times n is n squared. N times 1 is n. And that's equal to 420. So by the looks of this equation, it looks like a quadratic equation. So we're going to make it equal to 0 by transposing the 420 or subtracting 420 from both sides. So that's n squared plus n minus 420. And that's equal to 0. Alright, I think that all of that's worth 2 marks. So we've got to figure out, we've got to use the AC method. I'm going to have to, guys, make sure that you take off this working out right now. Pause the video, write it down, then unpause the video. So we're looking for, we're going to be using the AC method. So that's going to be 1, hope you guys remember the AC method. 1 multiplied by, so that's A multiplied by C. So that's 1 multiplied by 420. So we're looking for 2 numbers that can multiply to give us 420. But at the same time, if we subtract both of those numbers, we can get 1. Alright? Now, there's a lot of ways to do this. For the purpose of the video, I'm just going to get straight to the point. Alright? I'm thinking that maybe we could say, looking at this is a very big number. So we could probably split this 42 to see probably 2 multiplied by 21. Let's start there. Right? We're going to take out the 0. I'm trying to manipulate the number because the 0 is just, we can just remove the 0 and add it back when we finish. So I'm just going to be looking at just the 42. This is just a very unique way because when I see this number, it reminds me of some previous manipulation skills that I have. Now, if you don't have these skills, I could definitely show you like a few, right? You have to be connected with numbers to some extent. So I'm just going to get to the point and tell you what the numbers are for the purpose of the video. 2 times 21 is 42. So if I add a 0 here, that's still going to be 420. But what I also see is that if I put a 0 here, let's move this to, let's give it some space here. If I put a 0 here, I will still get 420. Double check that 20 multiplied by 21 is 420. And then right away, as I look at this, if you subtract these two numbers, 21 minus 20, you will also get 1. So we've gotten our answer. And this is just the purpose of the video, guys. It's a lot more, I should say, technical to get these numbers. But if you don't know how to manipulate numbers to get what you want, it's going to be a difficult process to understand. But the point is the answer, the factors are going to be 21 positive and 20 negative, so that we could get, when we multiply these two, we're going to get negative 420, and when we subtract them or add them, we're going to get positive 1. So that's it. Alright, so we're going to replace the middle term here. This is a lot more than 2 marks CXC. I believe that this is I think you're being stingy. Now, based on the fact that the coefficient of the, cut the working out short, guys, because I can see that this is going to take a long time. The mere fact that the coefficient of the n square here is 1, it means that my answers will work out to be n plus 21 and n minus 21, or n minus 20. Once your coefficient of your n square is 1, then your answers will just be the variable plus 1 of the factor and your variable minus the next factor. And if that is equal to 0, then I know that this cannot be my answer, because you cannot have negative amount of dots. It have to be n minus 20 is equal to 0, because when I transpose the negative 20, I'm going to get n is equal to 20. So by cutting out a lot of the working out, guys, because I can see that it's just 2 marks, so there has to be something that must be clear to the eye for you to see and to work out. Alright, so the answer here is 20. It's going to be the 20th figure that will have a total of 420 dots. Alright, so I know that there's a lot of little missing things here, but like I said, guys, I don't want to get into too much details to get to the answer. Yes, so that's why I've cut it short. Alright, so hopefully you get a little idea of what I'm talking about. Pause the video, take off this working out here, because I'm going to erase it for space now. Alright, awesome. Part E here, write a simplified algebraic expression for the number of dots D in the figure n. So basically what they want is some sort of formula. Write a simplified algebraic expression for the number of dots D in the figure. So D represents the amount of dots and n represents the figure. But we had initially written it down here. So here we have a half multiplied by the amount of figure times the amount of figure plus 1, and that's equal to the amount of dots. But if you look on the table, the variable that represents the number of dots is D. So we're going to just equate this to D. They want a simplified version. Again, I think this is stingy for 1 mark. I think that just writing this down alone is 1 mark, but they want it to simplify it. So we're going to multiply both sides by D. Remember that all of what's here together, because of the multiplication, they're all 1. So when I multiply this side by 2, the whole thing that's going to disappear is 2. So when I multiply all of over here by 2, I'm just going to get n, open bracket, n plus 1, and that's equal to 2D. I think that's simplified enough, but if you want to even go a little bit further, it's just going to be n times n is n squared, n times 1 is n. I'm going to subtract 2D from both sides, and I'm going to equate it to 0. All right. They ask us for an expression. I'm not understanding why they ask us for an expression, but then I'm ending up with an equation. Because they said for the number of dots D. Nevertheless, still, I don't think that if you do all of this, you're going to lose the 1 mark. But that's fine. Alright? It should not have an equal sign because of the fact they ask for an expression. So, anybody who is watching this, just let me know if I may have overlooked something, okay? Alright, so you're to show that there is no diagram that has exactly 1000 dots. 2 marks. No diagram that has exactly 1000 dots. It means that the diagram cannot be a decimal, like a 1.5 or a 7.5 or a 7.7. You can't have a rational figure. An irrational figure, I'm sorry. So we pretty much have to prove, I think that just looking at this, we're gonna have to prove that n cannot be equal to a decimal. Because if n works out to be a decimal, then it would simply mean that that diagram doesn't exist. So let's use this expression that we have here, this equation. N squared plus n minus 2d, because d represents the number of dots and you're saying that d is 1000, that's equal to 0. So if we try to factorize this and we cannot find the factor of 1 times 2000, if we cannot find the factors of 2000, it would simply tell me in essence that if I cannot find the factor, like when I was here and I found that the factors are 20 and 21, if I can't find the factors of 2000 that can give me back 1, it would mean that the values of n are going to be a decimal. So you can check that out. You can use the AC method or you can use the quadratic formula, and if you get a decimal for your answer, that's going to be your proof. But for the purpose of the video, n is going to be equal to a decimal, which basically proves that there's no figure that has exactly 1000 dots. Alright, so that's pretty much it. Alright, so we're gonna move on next to this diagram here. Question 9. And like I said, guys, the video may be a little bit lengthy in terms of how long it takes to go through the questions, because the idea is not for me to go through the questions and give you the answer. The idea is for you to understand how to approach the question. Okay? Alright, I'm gonna try to make this the last upload for this past paper. Usually I try to upload the whole entire video at once, but a lot of students don't like to watch the whole video at once. Yes, so I'm going to try to do it in parts. So we're at section 2, question 9. We are looking at a velocity time graph. So the velocity time graph below shows the motion of a cyclist over a period of 40 seconds. So this is the 40 seconds here, okay. And this here is the speed, the velocity at which the cyclist is traveling. Alright, that's fine. We're to calculate the gradient of OA. Now, if you're on the graph, guys, as mentioned before in part 2 of the 2017 upload, we mentioned that if you're on the graph and you're asked to find the gradient of a line, regardless of what the line is representing, and if you're on the graph, the quickest technique for finding the gradient is that m, which is the symbol for gradient. So we can say OA and put a subscript m here to say the gradient of OA is equal to rise over run. Because I'm on the graph. I don't need a point. You could use the point if you want to, but how much marks is it worth? 1? Don't think you want to go through all of that for 1 mark. So the rise would have to be this distance here, and 1 would have to be this distance here. And because I'm going down, the rise is going to be negative, and because I'm going to the left, the run to is also going to be negative. But when you divide the two negatives, the gradient here is going to be a positive gradient. So the rise here is going to be, okay, obviously I was at the bottom, so I rise here, so that's going up to 10, because this is the maximum 10. Remember we said earlier that if you want to know what each of these bright lines represent, or even small lines, you're simply going to take the maximum number, the height at which it goes, and divide it by the amount of lines that are in between. So if you wanted to know what each of these lines represent, that would be 10 divided by 1, 2, 3, 4. So that would be 2.5. 10 divided by 4, that's equal to 2.5. So 2.5 is actually the value of each of these. Not sure if I'm going to need that information, but I'm just going to jot it down to the side here. So the rise here is 10, and the run is going to be, well, it's negative 10, pardon me, negative 10, and the run here is going to be, well, obviously the scale down here is different, so this is 5, 10, 15, 20, 25, so the run here is going to be negative 25. So when you reduce all of that, I believe you're going to get 10 over 25, and if you go on your calculator and you check that out, then 10 divided by 25 is 0.4. So that's the gradient. You could leave it as 10 over 25 or reduce it to, let me see here, 2 over 5. That could work. So if you want a fraction, 2 over 5. If you want a decimal, 0.4. Okay? We also need the gradient of AB. So AB here. This is AB. Yes, that's AB. The gradient of AB is 0 because there is no rise. There is no rise. There is a run, but there is no rise. So if there is no rise, so if you were to even use the formula to say rise over run, then it clearly you see that there is no rise, and whatever the run is, let's say that the run is, let's just use what we have here, 5, 10, 15. Let's say the run is 15. Negative or positive. 0 divided by any number is 0. And it's very important to understand that this here is a constant. It's a constant speed, or it's a constant speed at which the vehicle is traveling. It's not increasing in speed, it's not decreasing in speed, it's just traveling at the maximum speed of 10. So when there is a constant speed, there is no gradient. So it's very important you understand that. Let's move on to the next page. We have to complete the following statements. The cyclist started from rest, where his velocity was, well, if you're starting from rest, obviously your velocity is 0. And it steadily increased his velocity by, well, if your velocity is increasing, that means you're accelerating. And if you're accelerating, then it must be accelerating by 0.4. If your speed is increasing, that means you're accelerating. If you read it carefully here, it says, and steadily increased his velocity by. A lot of students will think that it increased by 10. It did not increase by 10. They're trying to find out here that after every, let's say for every 5 seconds, at what speed is it increasing by? And that has to be the acceleration. But then again, they put meters per second to the -1, so I don't think that this is right. Because acceleration is meters per second squared. So I think that there may be some misunderstanding here. Let's go again. So, and steadily increased his velocity by, let's go back to our graph. Steadily increased its velocity by, oh, so this is where this comes in. Interesting. So you can see, even though I didn't think that I'm going to need this, it actually come in handy because every 5 seconds the speed increased by 2.5, then after 5 seconds 2.5, then 2.5 until it reaches maximum speed. So sometimes finding some information maybe, or finding information that's not heard sometimes come in handy. Very interesting, very interesting. And the reason why I knew that the answer could not be 0.4, because I know that the gradient of a line is equivalent to the acceleration of whatever the object is, whether it's a cycle, whether it's a bicycle, or it's a car, or it's a van, or whatever. So that is how I know right away that the answer could not have been 0.4, because the unit of measurement written here is meters per second. Acceleration is meters per second squared. All right, so we got that. Each second during the first 25 seconds. So during the first 25 seconds, let's go back to the graph. During the first 25 seconds, its speed increased by 2.5. So that's what it's saying. All right, so that's pretty good. We're working together, guys. It says during the next 15 seconds, his velocity remained constant. We had established that even without knowing this information. So that means his acceleration was 0. There we see that meters per second squared. Because we said it earlier. We said that if your velocity remains constant, it means that you're not accelerating. So let's say that you're traveling at a speed of, say, 20 meters per second. And it sounds like this. It means that that's a constant speed. Now, if your speed is constant, it means that you're not accelerating.